Since we were not able to go through this one in class, I'm going to take some time to explain this last problem that was on the last ACT. It was on the ACT that we did on September 23rd, and we never got to this last page. So it says, suppose the price P in dollars and the quantity X of sold of a certain product obey the demand equation (1/3 X plus 100). Construct a mathematical model that expresses revenue as a function of X. So one thing we need to know is revenue is equal to what we sell an item for, or its cost, or I'm sorry, let's just call it the price, times the number sold. Does that make sense? So like if I sell, I don't know, if I sell shoes at $50 a pair and I sell 10 pairs of shoes, I've made $500. You multiply the price that you're selling it for by the number that you sell. So our price function is provided by this P equation right there. So what we're going to do is we're going to substitute in for P. It's going to be (1/3 X plus 100. And then it tells us it's X products sold. So the number sold is X. And now I'm going to distribute the X in here, and we're going to get (1/3 X squared plus 100X. Now one thing is this is a function, so we're going to want to use the R of X notation. And so that's going to be our mathematical model that expresses revenue as a function of X. The next question says find the revenue when 200 items are sold. For this one, I'm going to plug in 200 for X because that's the number sold. So R of 200 is equal to (1/3 times 200 squared plus 100 times 200. And at this point, we would want to work this out using a calculator. So I'm just going to use Desmos for this. And I think even though this is a graphing calculator, I can just evaluate this. Oops. Sorry, guys. So it's (1/3 parentheses 200 squared plus 100 times 200. And that gives us, let's round this, 6,666.67. And that's a revenue, so that's dollars. Find the number of units that must be sold to maximize the revenue. So when we're thinking about maximizing or minimizing, we are looking for a vertex. We're looking for this top of this parabola. To find a vertex, we use the vertex formula, (b/2a). So let's figure out a is the coefficient in front of the x squared term, which is (1/3. And b is the coefficient in front of the x term, which is 100. So I get (b), so (100 over 2 times a, which is 1/3. Again, I'm going to use a calculator to help me figure this out. So I'll simplify it a little bit first. Oh, I got to fix something real quick. I'm sorry. A is (1/3, right? So this should be (100 over 2 times (1/3). (100 is just (100). 2 times (1/3 is (2/3). So what we're doing here is we're doing (100 divided by (2/3). So (100 divided by (2/3), which gives us, we can see gives us right here 150. So that is the number of units that maximize the revenue. So X equals 150 units. Determine the maximum possible revenue. Well, we're just going to plug 150 in. So it's going to be R of 150, which is equal to (1/3 times 150 squared plus 100 times 150. And I'm going to substitute that in. I actually think I'm going to go back. I can just change these to 150. and I get a revenue of $7,500. Finally, it says let's confirm our results graphically. So if we go to the graphing calculator, or Desmos, I'm going to change these to x's. And then we're going to look for this maximum. I'm going to bring this scale down a little bit so we can actually see the top of this parabola even more. Let's make this in too. Whoops. So we're looking for this point right here, right? And we can see it's 150, 7,500. X is the number of units sold, 150 units sold. The maximum revenue would be 7,500.